Hello everyone, I'm Tanishk and welcome to my channel. So I plan to start a new series of videos focusing more on giving out questions for individual topics because placements are around the corner, and I thought it would be helpful if we can just list out a few important questions from each topic so that it would give us a quick recap and it would help us answer questions with ease in our technical interviews. So what I heard was from my friends and from my seniors is that in for mechanical engineering students in technical rounds, questions are mainly focused from two topics, that is from fluid mechanics and hydraulic machinery, and also strength of material. So these are the two topics what they asked me to focus more on. Uh, this is not something very classified, but I'm just telling you because that's a pattern what most of them have observed. And so I've decided to bring out a series of videos wherein I would be discussing the frequently asked questions from each topic in interviews. So in today's video, I would be starting with fluid mechanics and hydraulic machinery. So, and this is something, the questions what I've taken from different sites what I've referred from the internet, and also uh, a list of questions which were given by institutions like Baba Homeotomic Centers and all, wherein they listed out interview questions in their sites. So I just picked up a few, and this is just to give an exposure, or probably these questions would cover like the most of the topics. So here we go with the first question. So the question, these are a list of 23 questions what I believe are pretty important for interviews, and I will be discussing answers for every question. The first question says, what is the meaning of fluid and mechanics? So to answer this, in an engineer's point of view, we can say that a fluid is a substance that flows, and also a fluid is a substance which shows definite and definite deformation to applied shear force. Like in solids, always do not show deformation when applied to shear force, but fluids definitely exhibit deformation when you apply shear force in them. So this is like a technical answer what you can give. And when it comes to mechanics, mechanics studies the motion and the forces which cause the motion, right? So that was the first question, like how you can answer it. Like I'm not giving you the exact answer how you can give, but I'm just giving you a broad perspective on topic so that you can answer it the way you're comfortable with. So coming to the second question says, what do you mean by fluid dynamics and kinematics? So fluid dynamics is a broader branch. We can say fluid kinematics is a subset of fluid dynamics, wherein fluid dynamics actually involves the forces acting on a particular fluid and the reason of the forces acting so. Whereas in kinematics, we just take into consideration what forces are acting and we just compute results. So this was the second question. Coming to the third question, they've given us four different properties, and they asked us to define them. So the first property being specific weight. So when I talk about specific weight, so whenever I define specific weight is nothing but the ratio of the mass of a substance with respect to its density. So that is specific weight. And when it comes to specific gravity, so specific gravity is a ratio of density of a particular object with respect to the density of a fixed fluid. For example, if I want to find out the specific weight of mercury, I would just divide the density of mercury with respect to density of water. So usually we take density of water as a reference, and that's how we compute specific gravity. Now coming to density, density is nothing but the ratio of mass and volume. And coming to specific volume, a volume is the reciprocal. Specific volume is the reciprocal of density. That is, it's the ratio of volume with respect to mass. And now, coming to the next question, this is a pretty interesting question. What I found, it says, why do we study specific volume when density is already there? So Yeah, since I already told you, like specific volume is nothing but the reciprocal of density. He says, why do we actually have to study specific volume? So when I start to compare things with the respect to mass, like per unit mass, if I want to observe how much a quantity is varying with respect to unit mass, that is per unit kg or some unit, I use specific volume. But when I want to refer a quantity or something with respect per unit volume, I use specific volume, sorry, density. Okay. So whenever I want to define my quantities with respect to mass, we use specific volume, and whenever I want to define my quantities with respect to volume, I use density. So the next question says draw a velocity profile for a fluid flowing over a flat surface. So for this, what we can do is that uh, just look at one second. Yeah. So when I actually have to draw a velocity profile for a fluid moving over a flat surface, let us consider this as a flat surface. The drawing is not very appropriate, and let's say the fluid is flowing in here with some velocity. Okay. So initially, when the fluid strikes this plate, it will lose its velocity. That means its final velocity becomes zero, and slowly the layer above it will lose a little velocity because there is the fluid, the layer above the plate, just above the plate, would lose a little of its velocity because the layer below it just stuck with the plate and it's providing a gap. So the fluid above it just cannot pass with the same velocity because there was some resistance observed and it will directly affect the adjacent layers. So similar, it goes on for a similar fashion for the corresponding layers until a particular point, and then after a particular point we would find the velocity same as the initial velocity here. So if you draw the profile, the profile would be something like this. So this would be the velocity profile of fluid flowing over a flat surface. So we're done with questions 5. uh, the next question says, how do you define bulk modulus? Now, bulk modulus in simple terms is represented by K, and it is nothing but the resistance against compression. So whenever I want to define my resistance against compression, I talk about bulk modulus. Now, the next question is again a practical concept, which says if you have a glass of water, if you have a glass, actually, this is an error in the question. If you have a glass of water, so which is having higher bulk modulus, either water or glass? So we know that fluids are basically incompressible, which means they exhibit higher resistance to compression. Um, Not technically incompressible, but to a greater extent they are incompressible. So that's why you can't actually compress water to a greater extent if you keep applying force on it. So so water shows greater resistance towards compression. So that's why water would have a greater bulk modulus when I compare it with my glass. The next question says, what do you mean by surface tension? So, surface tension is nothing but the force acting per unit area over a surface. Like, let's say there's a surface of water in here, and the force acting per unit area on the surface is called as surface tension. The next question what we see is differentiate cohesive and adhesive force. So when I talk about cohesive forces are the forces which basically represent the force of attraction between two molecules of the same substance. Okay. But when I talk about adhesive forces, they show the forces of attraction between two molecules of different substances. Like let's say the reason for water sticking on glass panels is because of adhesive forces, because there is a specific attraction between the molecules of the glass and molecules of water. So that's adhesiveness. So done with 9 questions, and here comes the 10th question, which says, "What is capillarity?" So whenever I consider a cylindrical column and the movement of water upwards or downwards in a cylindrical column is called as capillarity. So the next question is, why a water droplet is spherical in air? whereas a mercury droplet is spherical shaped everywhere. So the main reason for attaining a spherical shape is because of its surface tension. Okay. So water is also spherical in shape, right in the clouds, but once it starts to rain, it undergoes different forces like the air resistance and the drag, due to which it becomes a little elongated like a teardrop shape. But when I talk about Mercury again, Mercury has surface tension and density so high that it dominates all the other forces like gravity or any other resistance forces. That's why water would change its shape because gravity dominates its surface tension and density, whereas Mercury has those two factors very high. That's why it wouldn't change its shape. Now, what is the principle of non-sticking utensil? When I talk about non-sticking utensil, again, you can use the concept of coercive and adhesive force. That is, the adhesive forces are very less. Or you can also define that non-stick utensils are designed with uh, a concept having a very low coefficient of friction. That is, the anything what you pour over it just slides over it. So you can either answer the question in two ways. The first one, if you want to stick to the subject and talk about fluid mechanics, you can tell that the adhesive forces between any substance and a non-stick pan is very low. So that's the principle what they actually employ. Or you can also tell that the coefficient of friction is actually very low in design, and hence that's the principle of a non-sticking utensil. Now comes what do you mean by absolute pressure, vacuum pressure, and gauge pressure? So whenever I try to measure my pressure with reference to vacuum, it's called absolute pressure. That is, whenever I measure it with reference to zero, it's called absolute. And whenever my vacuum, what I call about vacuum pressure is the pressure measured is less than the absolute or the atmospheric pressure. Let's say the atmospheric pressure is 100, and the pressure what I measured is 80. So we've got a negative pressure lower than the atmosphere. So we call such things as vacuum pressure. Now, talking about atmospheric pressure is a pressure measured at a relative height, at a certain height from the Earth's surface. So, whenever I measure pressure from a certain height, it's called atmospheric pressure. Now, what about gauge pressure? As I told you, absolute pressure, we take zero as a reference. If I take my atmospheric pressure as a reference, I call it gauge pressure. Now, the next concept is define metacenter. So, this is a very technical question, what we can see. So, metacenter is like to understand the metacenter, let's first actually see what buoyancy means. So, when a object is immersed in water, water also, like in simple terms, water also gives a thrust to the body. So that's called buoyancy. And it acts over a point which is called a center of buoyancy. For example, let's say this is a box and there is some buoyancy acting on the body, and let's say this is the center of buoyancy. If you extend a line, you have a center of buoyancy, right? Now let's assume there's a small rotational force given to the box and the box starts to tilt. Let's say this is the new position of the box. I mean, my drawings aren't that correct, but just assume that the box has tilted a bit due to ocean waves or something. Just assume. So now there's a shift in the center of buoyancy. The center of buoyancy might be acting somewhat like this, right? In an inclined position. So for the box, this was the actual center of buoyancy. Alright, and this is the new center of buoyancy, right? So we observe that the center of buoyancy actually shifted. So this point is called as a meta center. Now, if the reason why we find out meta center is that if the meta center is above the center of gravity, the object floats, and if the meta center is below the center of gravity, the object sinks. So that's why meta center is important. Now, the next question is what is steady, unsteady, laminar, and turbulent flow? When I talk about steady and unsteady flow, if the mass flow rate stays constant, it's called steady. If it varies, it's called unsteady. Now, when I talk about laminar and turbulent, it's characterized based on a Reynolds number. That is, if the Reynolds number is Less than 2000, it's called laminar, and if it's greater than 4000, it's called turbulent. So there's something called as transition flow, wherein the Reynolds number varies between 2000 to 4000. So the next question states is in laminar and turbulent, which flow do you prefer? So actually, we prefer laminar flow because the flow properties are very much predictable again in laminar flow, and the damage to the components is a very much minimal when we compare it to turbulent flow. So we prefer laminar flow because we can predict flow properties, right? Now, the next question is what type of forces do you consider in the Navier-Stokes equation? So we consider pressure forces and viscous forces. This is like a broad idea. You can just explore it in some interviews. If the examiner is too stern, you might be asking to write the Navier-Stokes equation. So just also be prepared with it. Now, what do you mean by 1D, 2D, and 3D flow? So 1D and 1D, 2D, 3D flow, they represent the dimensionality of flow. For example, in 1D flow, they represent the dimensionality with respect to velocity. So if my velocity is dependent or it can be stated to a fixed point or fixed value, I call it 1D. But if my velocity is dependent on two physical coordinates, like x and y, I call it a 2D flow. And if it's dependent upon three coordinates, I call it a 3D flow. And you can also answer this question in a different way. If like my streamlines are straight, it represents a 1D flow. If my streamlines are a curve, it represents 2D flow. And coming to a 3D flow, if my streamlines are actually represented in a space or having three coordinates, we call it a 3D flow. So, what do you mean by continuity equation? So, continuity equation actually is an equation which states that it's actually based on the principle of conservation of mass, wherein mass is neither created nor destroyed. So, when I consider a pipe, the mass flowing at the inlet would be equal to the mass flowing at the outlet. So, this is basically your continuity equation. Now, 20th question. It's a very important question, I believe, because this is one type of question which I've seen come pop up everywhere. So, what is cavitation? So, cavitation is the phenomenon, like let's say this fluid passing in a pipe. So, when the pressure of the fluid becomes less than the vapor pressure of the fluid, bubbles start to form and they start to bombard the surfaces of the pipe and damage it. So, this phenomenon is called cavitation. That's a very important question. So, please pay a little attention to it. So coming to the next question, what are centrifugal pumps? Name a few parts. So centrifugal pumps are the pumps which are used to transfer, like pump basically is used to transfer the head of a water, like from one place to a greater height. So that's what a pump does. And if it uses centrifugal action, it's called a centrifugal pump. Like it uses an impeller which converts the rotational energy into pressure head so that water is transmitted at a greater height. So this is what a centrifugal pump is. You can have a look at a few animations if you want to just have a better idea. But since I'm just giving you a revision kind of thing over a concept, I guess this was enough. Now, a few parts of a centrifugal pump are the impeller, the casing, the shaft, and the vanes. So you can just name them. Next thing is what are the different types of pumps? So you got basically dynamic and positive displacement pumps. So when I talk about dynamic pumps, you have your centrifugal pumps wherein you use impellers. Now about positive displacement pumps, you got your piston arrangement due to which pressure difference is created. All right. Now, how can pump efficiency be improved? You can improve pump efficiency by actually performing regular maintenance checks and then also checking the pressure head and sorry the height to which water needs to be delivered, and selection of the pump is also very important. You just can't choose any random pump for any purpose. So selection, maintenance, and also kind of water being used, so all these are the factors which actually accommodate for pump efficiency. And So yeah, these were a few questions what I believe are pretty much important in fluid mechanics. If you if you guys actually need some more questions from the same topic, you can mention in the comment section so that I can actually bring out a part two of this video wherein I can cover some other questions apart from these topics. Uh, in the next video, I will mostly be starting strength of materials. And until then, thank you.